Welcome to the Math Practice Standards webinar series. This webinar will provide you information on the 8th Mathematical Practice Standard, Look for and Express Regularity in Repeated Reasoning. This practice is short and sweet when you compare it to the other 7 practices. We'll start by looking at it in its entirety, then we will unpack it. Mathematically proficient students notice if calculations are repeated and look for general methods and for shortcuts. Upper elementary students might notice when dividing 25 by 11 that they are repeating the same calculations over and over again and conclude that they have a repeating decimal. By paying attention to the calculation of slope as they repeatedly check whether points are on the line through 1-2 with slope 3, middle school students might abstract the equation y minus 2 divided by x minus 1 equals 3. Noticing the regularity in the way terms cancel when expanding, x minus 1 times x plus 1, x minus 1 times x to the second power plus x plus 1, and x minus 1 times x to the third power plus x to the second power plus x plus 1 might lead them to the general formula for the sum of a geometric series. As they work to solve a problem, mathematically proficient students maintain oversight of the process while attending to the details. They continually evaluate the reasonableness of their intermediate results. As you can see, there are specific habits of mind when students are proficient with this math practice standard. Let's break down each section so we can fully understand each of these proficiencies. The first statement in this practice means that students should notice the repetitive nature of a calculation and that they are able to make a generalization and/or find shortcuts. They see how the generalizations can help them solve a problem without having to be repetitive in their work. The next part states that students have the ability to keep in mind what the problem is asking so they can continually evaluate strategies being used. This helps them to refine their thinking and to see that there may be more than one path to a given solution. And finally, the practice concludes with students understanding that they must continually ask themselves if their answers make sense as they work the problem, not just at the end. This is a strategy that many students often overlook and oftentimes get to an end of a problem just to find they made an error at the beginning and they didn't catch it. So in turn, they basically have to start all over again. Let's move on to the implementation of Math Practice 8. This will involve the necessary planning needed for authentic tasks and problems to be incorporated in the lesson design. Planning for the math practices is looking at the actual student experiences that will occur as you teach the concepts. It's how the students will be learning the concept. These practices are not separate skill sets. They are embedded in content. As they are practiced, they become habits of mind. And each practice should be found in the pedagogy of all K-12 mathematics. It's important to choose activities deliberately. Choosing problems and tasks that create the habits of mind won't happen accidentally. Think of the questions at the bottom of the page in a textbook. The students multiply 2 digits by 2 digits in 20 algorithm practice problems. But did they notice that there are many patterns and shortcuts among these problems? A well-planned lesson will include inductive reasoning to seek patterns in computation. Tasks will require students to find solutions to generalized problems and be prepared to show the reasonableness for their answer. Students will find patterns in their computations and they'll be able to communicate with others how these patterns can be useful in solving the task. Remember, don't teach them the shortcuts. Let them discover them. But how do we know that our students are developing the habits of mind that call for them to look for and express regularity in repeated reasoning? We use questioning skills. We pose questions that are effective for our students and to ourselves, and we eventually want our students to pose questions to themselves naturally. As you design your student experiences, you should be constantly asking yourself if you are doing what it takes to create the essential habits of mind. You need to ensure that the types of tasks you select are engaging as well as lend themselves to the mathematical practice you want your students to have experience with. Create opportunities for your students to use mathematical reasoning and academic vocabulary as they work and demonstrate understanding. Have them look for and find connections within the tasks they are completing and real-world challenges. Don't give shortcuts. Oftentimes, these shortcuts hinder our students to delve deeply into the mathematics. Here are some questions to consider as you select specific tasks that warrant students to look for and express regularity in repeated reasoning. Do the activities and discussions in my classroom pose problems or tasks that draw attention to repetition? Do I encourage discoveries? Do I have students explain shortcuts when discovered in class? Tape these questions in your lesson plan book. Let them guide you. As we get better at asking ourselves questions during planning, we need to train the students to ask themselves questions too. Training should begin at a very young age and should create lifelong habits. As teachers, we should ask the students these questions as they are engaged in the tasks, with an emphasis that we want to help them develop the habit of asking themselves these same questions. What do I know about this problem? Are there any patterns when I work with numbers? Do I notice when calculations are repeated? Did that work? If not, what else can I try instead of just giving up? Do I use shortcuts? How is my answer like others? Are there different ways to solve this? Now it's time to get more specific about the types of activities and tasks that it takes to provide the desired habits of mind for Math Practice 8. We were all taught multiplication in 3rd grade, but what was the approach? I remember standing and recalling each of the math facts and getting a red star on the class chart. I might have gotten a Tootsie Roll too. This problem asks the students to notice that multiplication is repeated addition. Write 5 times 4 as an addition problem. And here you can see their answer. By solving this type of problem, students simply begin to understand that multiplication is actually an addition shortcut. They don't often see that when they are just practicing their math facts alone. And who doesn't love a quick multiplication trick? Just add 0 is a prime example of regularity and repeated reasoning. Do you know that I actually have to teach this to several middle school students every year? They'd rather just put everything in the calculator. And think about long division. It's not so bad for your students once they have learned the repeated patterns. What does it mean to use properties of operations in the primary grades? The focus is not learning names for the properties, but on understanding how each operation behaves. For example, that the numbers in an addition expression can be rearranged without changing the sum. Problems such as, how do you know that 23 plus 2 equals 2 plus 23 are great problems to have students have to explain their thinking. And the added benefit is that by their answer, you can see if they are becoming proficient in understanding the property of operations. Here's another task to consider. Nina was finding multiples of 6. She said, 18 and 42 are multiples of 6, and when I add them, I also get a multiple of 6. 18 plus 42 equals 60. Explain to Nina why adding 2 multiples of 6 will always result in another multiple of 6. When students demonstrate Math Practice 8, they notice if calculations are repeated and look both for general methods and for shortcuts. They are asked to generalize why when adding 2 multiples of a number, 6 in this case, will always result in another multiple of the same number, 6. This task would be most useful to assess the student's depth of understanding in generalizing repeated calculations and applying the distributive property to show that 2 numbers with a common factor can be expressed as a multiple of a sum of 2 whole numbers with no common factor. This could be accomplished by having students work independently on this task after multiple opportunities to solve similar problems dealing with multiples, factoring, and the distributive property. The students could then share their solutions with other students and discuss similarities and differences in their solutions, finalizing their answers, making sure to explain their thinking with numbers and context. The teacher could use these solutions as a formative assessment to guide small groups of those students who are not seeing the benefit of Math Practice 8 to solve this task, into seeing the generalizations that stem from it. This will be beneficial for all students as it is a rehearsal for algebra. This task is perfect for assessing Math Practice 8. Michael stated that the sum of 3 consecutive numbers can be divided by 3 to find the middle number. Is Michael's thinking correct? If so, why do you believe this method works? If not, provide a non-example. This problem provides room for discovery, discussion, and reveals a pattern in mathematics. And for our last task to view, consider this genie question. We have all seen the genie question in some form or another. After opening an ancient bottle you find on the beach, a genie appears. In payment for his freedom, he gives you a choice of either 50,000 gold coins or 1 magical gold coin. The magic coin will turn into 2 gold coins on the first day. The 2 coins will turn into 4 coins total at the end of the 2 days. By the end, or the 3rd day, there will be 8 gold coins total. The genie explains that the magic coins will continue this pattern of doubling each day for 1 moon cycle, or 28 days. Which prize do you choose? When you have made your choice, answer these questions. The number of coins on the 3rd day will be 2 times 2 times 2. Can you write another expression using exponents for the number of coins there will be on the 3rd day? And write an expression for the number of coins there will be on the 28th day. Is this more or less than 1,000,000 coins? The teacher could pose this task with small or large groups and lead them through creating a table to demonstrate the repeated calculations necessary to solve this problem. Once the pattern has been discussed, the teacher could have students begin to discuss the exponential growth demonstrated by the table, solutions to the questions posed in the task, and guide the students in using the repeated calculation to find an expression that could be used to efficiently solve any question that could be asked about the exponential growth. So now that you have viewed some tasks that hit on Math Practice 8, how do we assess this math practice? How do we know that our students are proficient in it? Students can be assessed informally during this process just by asking questions as you circulate. I suggest allowing the written portion of each task to guide your evaluation of the math practices. Did your students discover deep underlying relationships that unify the various aspects of a problem, such as a discovery of an underlying function? Some teachers may want a more formal rubric. This rubric can be used or adapted as a quick reference to assist with the assessment. An emerging student can look for obvious patterns and use if-then reasoning strategies for obvious patterns. A proficient student can find and explain subtle patterns. And an exemplary student can discover deep underlying relationships that unify the various aspects of a problem, such as a discovery of an underlying function. It may be valuable to assess yourself as well. This rubric is a great planning tool as you design your lessons. As we become more self-aware of the environment we create, and if it is effective in implementing the math practices, we should see a direct impact on the problem-solving and perseverance of our students. As we conclude this webinar, consider planning tasks that naturally embed math structures and repeated patterns. Don't give the answers to your students. Let them self-discover these patterns, and as they do, you will find that many will become proficient in this practice. We hope this webinar helped clarify your understanding of Mathematical Practice 8. Look for and express regularity in repeated reasoning.